Hello, in this video we will review how to calculate the moment of a force, something which you typically learn in physics or statics. However, it's something that gets students confused a lot, especially with regards to this note here, that the moment of a force is a vector that is calculated from a cross product. So the moment is a vector, it's not a scalar. So if we have the force F here applied at point B, how do we find the moment of the force F about point A? The moment of the force F about point A, I'm going to call it M. Vector is equal to the position vector from A to the point of application of F. So that vector, that's equal to RB minus RA. The position vector, RB minus RA, crossed with the force. So again, here that's the position vector from the point at which we're trying to find the moment about to the point of application of the force. Position vector from the point at which we are trying to find the moment about, we want to find. About to the point of application of F. Now, strictly speaking, we can relax this constraint a little bit. We do not have to find the position vector to the point of application of F exactly. We just need to find the position vector to some point along the line of action of F. So forces are typically sliding vectors, and whatever component the position vector, whatever component the position vector is gonna have parallel to F is not gonna enter into the cross product, right? Because the cross product of parallel vectors is zero. Okay, so this is the definition of the moment of a force. Let's do some example. Okay, I'm gonna consider a particle moving on a circle. Consider a particle moving on a circle. Okay, so this is my origin. I'm gonna choose my basis, EX, EY. I'm also gonna use a polar basis. So this is my particle. Let me draw it in green. And this is the position vector to my particle, R, right? Which is easily expressed in the polar basis. R is the radius of the circle, called big R, ER. And let us have some force P that is just horizontal, acting on the particle. What is the moment of P about the origin O? And P is acting on the particle, right? So that would just be M is equal to the position vector from O to the particle, which is just the position vector of the particle, right? R crossed with the force P, which is RER crossed with PEX. Okay, here we have to be very careful. So these two vectors are expressed in different bases, so I cannot use the determinant to calculate the cross product. One way to calculate this cross product is I can just take the scalars outside. ER I can write as cosine theta EX plus sine theta EY crossed with PEX, and then I can take the cross product of each term like that. EX cross EX is 0, so that it's gonna be 0, and then EY cross EX is minus EZ, right? So I'll get RB sine theta EZ. That's my answer here. Right, because remember your right hand rule, or you can think of this little circle as I'm going counterclockwise. My cross product is going to be positive, and then clockwise my cross product is negative. So EY cross EX goes like this is equal to minus EZ.